welcome to lecture number 7, and we have been discussing with two important methods of solving networks, that is the mesh analysis and the nodal analysis. In our last class, we went up to this that nodal method for solving network. Just remember that current in any resistance, just reviewing that part very quickly, current from x to y will be given by V x y. We know what these two suffixes x and y means. It means potential of x with respect to y. So, current direction, since we are interested to know from x to y, so you have to take V x y and that you have to divide by the resistance. That is the essence of this thing. Now, then I told you that in a network there will be several nodes. Each node is defined as the junction of at least 3 element ends, for example, A, B, C and O. And then I told you that if by chance, if you know one of these 3 nodes you take at reference O, any one of them. So, I have taken this to be as my reference node. So, with respect to that, VAO, VBO and VCO are called the node voltages, and what I told last time, if by chance I know these 3 node voltages VAO, VBO and VCO, I am telling that you have solved the circuit, because if you are now to find out the currents in any of the branches, for example, in this branch, if you want to find out the current, that current will be potent. You grab the resistance of that particular path, for example, R 3, and see what is the voltage difference there. This potential, this end potential is certainly VAO. I know with respect to same point I have to calculate the potential of this. Now, from how can you reach this point? This point you can reach VCO. Then you see there is a voltage drop here. So, potential of this point with respect to same point O will be then VCO minus E 4. That is why the current in I 3 in this direction is VAO minus potential of this point, which is VCO minus E 4 by R 3. Similarly, the same thing I have applied to other branches as well. The point I want to make is that if the potential of these 3 nodes are known with respect to one of the nodes being defined as a reference node, then you can find out the currents in any of the branches. That is the essence of the thing. Now, I started my discussion telling that VAO, VBO, VCO are known, then only you can do this. Now, the question is, how can I find out VAO, VBO, VCO? That is the our aim will be, given a network, after identifying the node, choosing one of them as a reference, then try to find out the node potentials of other nodes. So, how to do it, that is the thing. So, let us see, suppose what I draw another circuit which may not be exactly same, but similar type. See, suppose you have a network like this, and here is some resistance, there is some source, okay, and there is another resistance, some source, here is some resistance here and some source here. So, and there is another elements here. Suppose this is a resistance and this is another source. Okay, so I identify the nodes as usual. This is one node, this is another node, this is another node, this is another node, and I choose this to be as a reference and say that this node, name of this node is A, this node is B, this node is C. Our target is to know to solve for VAO, VBO and VCO. That is, we are not targeting to calculate the currents in the branch straight away. We first calculate the node voltages, and as I told you, if these voltages are known, calculation of currents in any of the branches is taking the difference, dividing by the resistance, etc., will come in. Now, how to solve this thing? And let me also add another thing here. Suppose here is also a current source, just to a fixed current source, ideal current source is connected here. Now, what is done is this: to solve for VAO, VBO, VCO, write the KCL at nodes A, B and C. That is what you have to do. So, at node A, KCL is the common thing at node A, what it will be. And suppose these values are known, this is E 1 plus minus R 1, this is plus minus E 2, this is R 2, this is plus minus E 3 and this is R 3 and this is suppose some R 4, this is minus plus E 5, E 4, E 2, E 3, R 4. Say this is E 4, how does it matter, and this is R 5, this is E 4, this is E 4, and this is R 5, this is R 6, and this is plus minus E 6 suppose. So, this is the circuit and there is also a current source connected. Now, at node A KCL, when I will calculate, I will always calculate currents flowing away from node A, in this branch this way, 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 and sum of all the currents then will become 0. That is the whole idea. Of course, all currents I will calculate away from the circuits, you be rest assured that at the end when you get the numerical values, some of them, that is current going away from the node, will become negative, indicating they are really coming out. So, we because direction of currents is decided by me. So, I just say that okay, I will calculate current emanating from this node in this direction, in this direction, in this direction and in this direction, and sum of all the currents will be 0. So, first calculate this current. This current will be in terms of node voltages VAO, potential of this point, divided by minus potential of this point, that is to be noted, that is VAO minus what is the potential of this point with respect to O? Very simple, plus E 1. Divided by R 1, this will be the current here. If somebody had assumed current flowing from below to top, then he would have defined current, that current to be E 1 minus V O by E. I think you have understood the point. So, this is this current. Similarly, what is this current? This will be plus this current plus this current. Potential of grab the resistance, try to find out the potential difference between these 2 points. So, this is V A O minus potential of this point with respect to O, and that in terms of V B O, it is V B O plus E 2 minus V B O plus E 2 plus this will be the, and that divided by R 2 will give me current in this direction. There is altogether 4 currents are branching off from A. So, 2 I have taken, third one will be similarly plus of V A O minus E 6 plus V C O, is not V C O plus E 6 is the potential of this point, this resistance potential difference, this divided by R 6. So, 1, 2, 3, 1, 2, 3, these 3 currents are emanating. Then this is the current source S I am writing. Then in this direction the current source I have shown to be like this. So, this must be minus I s, which is coming out from A this way, and this must be 0, this must be 0. So, what is my job? My job is to generate 3 equations involving V A O, V B O, V C O and solve them to get V A O, V B O, V C O. So, this is one of those 3 equations, mind you. Now, this equation, if you collect, if you try to find out the coefficients of V A O, it can be written as 1 by R 1, collect these terms involving V A O plus 1 by R 2, this will give plus 1 by R 6 into V A O. This will be the coefficients of V A O. What is the coefficient of V B O? You can see that is this term minus 1 by R 2 into V B O. Then what will be the coefficient of V C O? This is minus and this minus goes in plus 1 by R 6, is not plus or minus V A O minus V C O plus E 6. So, this I wrote wrongly, plus all sum of the all the currents coming out is 0. So, this is plus. So, this once again will be minus 1 by R 6 into V C O. And then on the right hand side I will write down the sources. For example, it will be E 1 by R 1 on the right hand side, and then this E 2 by R 2 minus. So, it will go there, it is also plus E 2 by R 2, and then plus once again E 6 by R 6, and then there is another current source that will also I will write it here, because these things will be known, sources are known, I want to find out the currents. So, this will be equation 1 for this network. Got the point? Therefore, see dimensionally on the left hand side voltage by some impedance, current ampere, this is also ampere, this is also ampere. So, right hand side also matches, each one of them is in ampere. So, this is one of the independent equations involving V A 0, V B 0, V C 0. Now, after writing down these equations, we see there is a pattern. If you are writing down the KCL at node A, the coefficient of VAO will be sum of reciprocal of all the resistances connected at node A, that is 1 by R 1 plus 1 by R 2 plus 1 by R 6, and in this branch there is no resistance, nothing is coming. Coefficient of VBO will be any resistance connected between A and B, because I am writing at node A. So, A is at the central point, whether there is any common resistance between A and B, yes, R 2. So, reciprocal of that resistance, but preceded by a negative sign VBO. Similarly, coefficient of VCO, it will be minus 1 by R 6, because there is a common resistance between A and C, which is R 6. This is what I will only remember. Therefore, this will be the first equation. Similarly, following this logic, of course, this I have written by rigorously writing each term from the fundamental things. Then after that writing I discover, oh, there is a pattern, that you must understand. So, similarly, I can write from very basics the KCL here, this current, this current, this current, sum of this current is 0, then keeping VAO, VBO, VCO on the left hand side, bringing all the sources on the right hand side, I can get that. Now, coming to this first equation, what about the right hand side? Right hand side, as I told you, this will be all sources. So, for example, E 1 is a source and it has to be current on the right hand side. So, E 1 divided by the resistance in series with E 1, that will be the term here, E 1 by R 1, and whether should I write plus or minus? It will be plus if the current, natural direction of the current that E 1 is supposed to deliver with regard to this polarity is E 1 by R 1. That is, if the positive of the battery is connected to node A, then it will be plus E 1 by R 1. Similarly, there is a current source here, voltage source here E 6, which is via R 6 connected to A. So, this term will also come and this will be E 6 by R 6, because after all it has to be amperage, E 6 by R 6, and plus is connected towards A. So, plus. So, this is this term. Similarly, about E 3, it will be E 3 by R 3, because plus is connected towards B. Why E 3 I have not written? Oh, another term will be there, na? Plus, because there is another source. Where is E 3 here? Oh, E 3 is not there, it is not involved. At node A, this E 3 R 3 are not involved. So, this is, that is all, that is correct. So, this is first equation. Now, let us write down KCL at node B. At node B, in the same way I will write because at node B at the center stage now. So, coefficient of VBO will be sum of the reciprocal of all the resistance connected here, 1 by R 2 plus 1 by R 3 plus 1 by R 4. And this should be VBO. If you simplify that writing from basics. Coefficient of VAO, will it be present there? Yes, because between A and B there is R 2. So, it should be minus reciprocal of that resistance into VA 0 plus, and coefficient of VCO, yes, minus 1 by R 4 into VC 0. Left hand side is over, and right hand side will be, all these sources will appear here in the form of currents. Therefore, you see there is a battery connected here to B with plus connected towards B. So, there will be E 3 by R 3 and that will be positive. So, right hand side E 3 divided by R 3, this is correct. There is another battery E 2 connected here to B. So, this E 2 by R 2, E 2 by R 2, but it negative is connected to B. So, minus E 6 by R 6 will not appear at B, because they are not connected to node B. Between B and C there is no source. So, only these two sources, but note down the, and no current source is also not coming at B. So, that is all. This is equation 2 here. And I will write also the equation at note C on the same page. It will be congested, but let me write it here with a different color. So, everything is there on the same page. At note C, what it will be? So, let me rub this off. Now, the third, at note C, what will be the equation? Let us write. And at note C, at node C, KCL at node C. I can once again start from the basics, but I will not do that, because I know there is a certain pattern in which the coefficients of VAO, VBO and VCO are decided. So, at node C, coefficient of VC 0 will be sum of reciprocal of all the resistances connected to node C, that is 1 over R 6 plus 1 over R 4 plus 1 over R 5. This will be the left hand side, and coefficient of VC 0 is this. Coefficient of VB 0 will be minus 1 by R 4, minus 1 by R 4 into VB 0 will be the thing. This is VB 0, and coefficient of A 0 will be minus 1 by R 6 into VA 0. And this will be equal to, this is VC 0. Okay. This will be equal to sources, right hand side sources. So, at C 0 there is E 6 by R 6 will appear, but negative is connected to C. So, it should be minus E 6 by R 6, this will be the current. In this branch, no resistance, no term appears, sources is not present. Here in this case, it will be once again minus is connected to C. So, minus E 4 by R 5. So, this is the third equation. In essence, what I am trying to tell, in nodal analysis, you identify the nodes. If total number of nodes, if n equal to total number of nodes, then you have to generate n minus equations, solve, you have to solve n minus 1 equations. For example, here n equal to 4, so 3 equations and 3 node voltages you have to solve. Now, in conclusion, I will say that to write down the KCL at the different nodes, I will not start from scratch. After knowing this, I will straight away write down these equations by inspection. I will not spend any further time to once again scratch my head and see this way current is flowing, that way. No, I will not do that, because that I have done for the first time, and then I soon discovered that there is a pattern existing, and then I will encash that thing to write down all the 3 equations in no time practically. I mean, very quickly, you have to be very fast and write down this equation and get it. So, number of equations to be solved here is 3. Is that point clear? Now, so in the mesh analysis, number of equations to be solved in general is equal to the number of meshes present in the network. What is a mesh? We know. Number of equations to be solved, if you want to adopt nodal method, is n minus 1, where n is the total number of nodes. We have seen that in mesh analysis, if you are lucky that in one of the outermost meshes there is a current source, then number of equations to be solved will be even less than the number of meshes, 1 less, is not that we have learned. Now, in this case, I have not discussed that aspect, whether it is always n minus 1 equations to be solved, or also there may be situations where number of equations to be solved may be less. For example, let me consider, just draw a circuit like this, and it will bring out another thing, that suppose you have a network. Now, I will write some numbers, so that you understand what I am doing. Suppose you have a network like this, and I will bring out another important concept as well. Suppose this is the thing you do. Okay. Now, let me put some numbers, say this is 4 ohm, this is 2 ohm, this is 6 ohm, this is 8 ohm, okay, and this is 10 ohm. Let me write, you can also make your own circuit for understanding this thing, and this voltage is suppose 10 volt, this is suppose 5 volt, and this is suppose 2 volt. Okay. Now, this network has got suppose another branch. This point you listen carefully what I mean to say, and here is an ideal battery. No internal resistance, plus minus, and this is suppose 4 volt. This network problem you have to solve. Now, the point is that okay, if you assume mesh analysis method, there are 3 meshes very clearly. So, assume I 1, I 2, I 3, and you can generate those 3 equations by inspection. Coefficient of I 1 will be sum of all the resistances, etcetera, like that, and writing sources on the right hand side. Now, suppose I insist that solve this network by nodal method. Now, in the nodal method, the first thing is you identify the nodes and name them. For example, you name it A, B, C, and suppose O. And then your target will be to solve for V A 0, V B 0 and V C 0, if you have chosen O as your reference node. Okay. And we know how to write down the KCLs at the different nodes. Now, suppose I have chosen O as my reference node, then coefficient of VAO, that is KCL, at node A. Suppose I want to write down node A. What is the rule I told you? Coefficient of V A 0 will be sum of reciprocal of all the resistances connected to A, that is 1 by 4 plus 1 by 2, and in this branch there is an ideal battery. So, resistance here is 0, that is it should be 1 by 0. It looks like, I mean the way I told you, and this should be coefficient of V A 0, then coefficient of V A 0 will be 1 by 2 into V B 0, and coefficient of V C 0 once again is a dreaded term, 1 by 0 into V C 0, because common resistance between A and C is 0 resistance, and this should be equal to the sources whatever it will there will be also some problems. So, it looks like you cannot proceed. What you will do with coefficient V A 0 as a becoming infinity? You cannot solve such equations, is not. So, there is, it looks like there is some inherent problem, and in fact, it is an inherent problem, and we will discuss this very interesting aspects in my next class. Thank you.